SwayamPrabha. Digital India. Educated India.
Welcome back. In lecture 7, we will talk about different types of water demand. So, the different concepts that we will cover in this lecture are domestic water demand, industrial water demand, institutional, commercial and other water demands. Then we will look into the fire demand, and finally, we will look into different factors that affect per capita demand. So, when we talk about domestic water demand or the different types of demand in an urban area, so we have to understand, in our previous lecture we have talked about demand forecasting. So, that is for long term period and also for short term period. But usually for in all different countries, governments define certain standards. Like for example, in India we have got the Bureau of Indian Standards. They have defined this particular guideline 1172/1993. This is the standard that is used to determine what kind of water should be used, what kind of water is required in urban areas, and what should be the different standards that we should use while we define when we design certain infrastructure or when we design certain projects and so on. Now, why the standards are there? Because if standards are not there, anybody can predict anything and they can actually use any kind of values, right. So, government actually fixes this standard so that at least this amount of values has to be adhered to. So, this kind of standards has to be adhered to. So, there are the benefit of this is everything is standardized, but the same thing is the government also needs to update these standards at certain intervals, and that is where the forecasting and this research comes in, right. So, the government will use forecasting to actually determine what kind of standards it will set for particular urban areas. But once it sets a standard for that particular time period, before it is changed, people have to use these standards while we design certain projects, certain infrastructure and so on. So, when we talk about domestic water, and then people can also make different kinds of project. It could be a real estate project, it could be a township project, it could be the overall urban area that we are planning for, it could be only an extension of a urban area like a satellite township and so on. So, there could be different kinds of project. It could be a CBD development project, it could be an industrial park development project. So, we need to understand in each of these particular places what amount of water is required. So, some of it could be determined through the standards, but things which are not covered in the standards or where we understand that standards are not adequate, there we can always go back to forecasting methods as well. Okay. So, when we talk about domestic water demand, the first thing that we need to understand is this is for residential population, right, and residential population lives in different residential units like certain kinds of housing units. Now, there has to be certain standards when we talk about that. That means, when we are determining water demand for a particular area, we say that how many 1 BHK apartments are there or 1 BHK housing is there. 1 BHK is 1 bedroom dwelling unit, or 2 bedroom dwelling units, 3 bedroom dwelling units, 4 bedroom dwelling units and so on. And based on this dwelling unit, we determine what is the population that is there, right. So, we say that around, or we can go vice versa. So, if we know the overall population, from there we can based on certain surveys and all, we can estimate number of each kind of dwelling unit as well. So, we can go both direction. So, but we need to make sure that we assume that for 1 bedroom dwelling unit there are 4 persons for whom we have to supply water. For 2 bedroom dwelling units there has to be 5 persons and so on, and 4 bedroom dwelling units 7 persons, whereas for EWS there will be 4 persons, and for studio apartments 2 persons, right. And this includes both the residents as well as the support staff who work in this particular dwelling units. And So population has to be estimated for an area or development using this above figure. So for a particular area, when we determine per capita demand of water and all, based on the kind of housing units and all, we determine the population, and then based on per capita water that has to be supplied, we determine total amount of water that is required for that particular area. So over here you can see that communities with the IS standards or Indian standards says that communities with population up to 20,000, for this kind of communities, if water supply is through stand post, that means it is not through home door to door, or it is not through piped water supply to your houses, but through common stand post that from where people go and collect water. So here around 40 liters per capita per head per day can be supplied. So this is the minimum value of water that has to be supplied. If water supply is through house connection, so at least 70 to 100 liters per capita per head per day, liters per head per day has to be supplied. So this is for a population which is around 20,000. So these are for small communities, right? And as you understand, small communities maybe involve some houses clustered in a particular semi-rural setting and so on. But in urban areas, because there are so many other uses, we have to have not only water for domestic use, but many other things like that some people may have a roof garden and all these things are there. So for that also we have to cater to. So there the water demand is higher. So communities with 20,000 to 1 lakh population, so this would be 1 lakh, sorry, and with full flushing system, that means sort of a water carriage system or a sewerage networks are there. In that particular case, we have to supply from 100 to 135 liters per head per day. For economically weaker sections and LIG colonies, 135 liters per head per day is adequate. So these are the basic standards that are there. But again, as I am telling you, if I am going to develop a project where I am going to design only high-end residential apartments, we may have to supply more water, right? So that is what we will look into after this. So when we talk about domestic water use, we can break down the domestic water use into different components. And as you can see that over in this particular table, we can see that 5 liters per capita per day is reserved for drinking, for another 5 liters for cooking, 75 liters per capita per day for bathing, 25 for washing clothes, 15 for washing utensils, and so on, and 45 liters for flushing of water closets and so on. So this comes to around 200 liters per capita per day. So this is the amount of water that is required for standard uses, right? Now for poor communities and all, we can see that this liter per capita per day comes to around 135 liters per capita per day. So this you can see are for basic uses that happens in domestic within houses, right? So this is what is there. So this is how much amount of water is being used. So this doesn't includes any other kind of use like watering of the surrounding neighborhood or the public amenities, like there is a park. So who will give water to that particular park? Of course, these people are not going to give. The urban authorities have to water those particular parks and all. So that use is something separate. So this is purely domestic use. For well-off families, we see a range of around 200 liters per capita per day. For poor families, 135 liters per capita per day is something which is okay. And when we talk about this domestic demand, some amount of demand could be supplied by municipal sources, some amount, if it is not adequate, has to be supplied from their own resources, right. So over here, even though we say that communities with population around 1 lakh, more than 1 lakh, with full flushing system, they have to be supplied with 150 to 200 liters per capita per day. So that actually is fine, but obviously people can also have their own water sources as well. So domestic water demand includes water required in private buildings for all the different purposes that we talked about. And while IS code specifies water consumption around 135 to 200 liters per capita per day, in developed countries or well-off countries, we see this as high as 340 liters per capita per day. And similarly, very well-off areas in our country also, we will see the water demand to be much higher. So these are the minimum standards, so we can always supply more than that. So, domestic water consumption is around 50 to 60% of the total consumption. So, even though this is liter per capita per day, but this is only for domestic use, not for any other use. So, let us look into the other uses. So, the next use that comes to our mind is the industrial water demand. That means, in an urban area there are also a lot of industries. So, usually we assume that the per capita consumption for industrial demand for a city, if there is not too many, if it is not a primarily a industrial city, there are few industries, small industries scattered all around, and then we assume around 50 liters per person per day as the demand for water for industries, because in addition to houses there are also industries in an urban area. So, for them we assume the water that has to be supplied is around 50 liters per capita per day. Now, will this water be supplied by the municipal corporation, or will the industry dig in their or put in their own tube wells to draw water from the ground? So, that is a different question, but this is the water that is required. Now, as I was telling you, in case there are larger industries, for example, there is a steel plant, or there is a automobile factory, or there may be a petroleum refinery. So, large kind of this kind of larger industries, they have a huge water requirement, and either they have to make sure that they get the water from their own sources, maybe they are pumping water from a river, or they may be drawing water from the ground. So, this has to be separate estimated for this particular industries. So, this may be supplied by the municipal corporation, this may not be supplied, this may be supplied by the company itself or this industry itself, but we need to estimate how much amount of water would be required, because that is the water resource that would be spent, and this water resource will come from the surrounding aquifers, right, or from the surrounding surface water sources. So, this needs to be estimated. So, this particular table you can see for different kind of industries, for unit production or raw material used, we are this is showing the approximate quantity of water required per unit of production or raw material in kiloliters. So, for example, for producing one vehicle, 40 kiloliters of water is required. For producing 1 kiloliter of alcohol in a distillery, around 122 to 170 kiloliters of water is required. So, you can understand the amount of water that is consumed to produce only 1 kiloliter of 1 liter of alcohol. Fertilizer for 1 ton around 80 to 200 kiloliters. For leather tanned 1 ton 40 kiloliters. Paper, 1 ton of paper requires around 200 to 400 kiloliters of water, and so on. So, this is how we have to estimate the industrial water demand for an urban area, which is in excess to the standard water demand, and if this kind of industrial demand is not there, then we go for 50 liters per person per day. So, this we will add, even in any case we will add this particular 50 liters, because some smaller industries are there in all urban areas. Then comes the institutional and commercial water demand. So, in any urban area there are both different institutes, different offices and different retail stores. So, these are the different other kinds of land uses that are there in an urban area, and here we assume that around per capita water demand of around 20 liters per capita per day is usually considered for this kind of uses. But if it is a very commercialized cities and there is lot of land use dedicated to either institutes and commerce, then we can go for 50 liters per capita per day. So, it could be a range somewhere between 20 to 50 liters per capita per day. Now, if I really want to do a detailed estimate, because sometimes in between 20 to 50 liters there is a huge range, right, and this will change the overall water requirement for a particular city. And why, particularly for large cities, the water this variation is pretty large, and if it's the resource is scarce, that means we don't have adequate water, we really need to be careful about estimating the volume of water that would be required for a particular city based on its land use characteristics, based on the number of institutions or number of commercial buildings or commercial establishments that are there. So, how do I do estimates of that? So, water requirement for individual institutions and commercial establishments could be determined using this kind of a table, where you can see that for offices we usually consume around 45 to 90 liters per capita per day. So this is in addition to the residential water demand, because some part time of the day these people will particular person will spend in the office and some time he will spend in the house. It's not like they would so both the demands would be required. And for factories where there are bathrooms, it's 45 to 90. If there are no bathrooms, then there is 30 to 60, which is less. For schools, day scholars, 45 to 90. For residentials, it's similar to normal houses, 135 to 225. For hostels, around 135 to 180. For hotels, 180 per bed. Restaurants, 70 per seat. And so hospitals, 340 per bed. For smaller hospitals, for larger hospitals, maybe 450 per bed, and so on. Similarly, for railway stations where you need to provide toilets and all, 70 where bathing facilities available, 45 per capita per liters per capita per day where there is no bathing facility, and so on. So similarly, we have to estimate the total volume of water required for this institutional and commercial water demand. So if we have detailed data on this kind of land uses or buildings, we would be also able to do that. So in addition to industries, institutes and commerce that is there in an urban area, and of course residential land use is there, we also have lot of areas which are dedicated for public use, like landscape areas, like plazas, like your public parks, certain amount of areas where there is plantations, right. So for that we have to also use we have to also water those particular areas. So in India, we assume around 5% of the total consumption is considered enough to meet this demand. So you can also take, instead of 5%, you can take around 10 liters per capita per day can be also added to take into account this kind of water requirement in a particular city. Again, I am telling you, if you can always go for a much more detailed estimate. So losses and waste, finally, once all these things are estimated, we know that some amount of water is also lost in the system because of leaks, because of thefts, because of certain other things, like for example, bad plumbing, defective joints, damaged water meters, unauthorized connections, and so on. And so usually it is assumed around 15% of total consumption. So that is what is for a new network, this is fine. But for an old network, and in Indian cities, we usually see values typically ranging from 30 to even 50%. So you can understand the amount of water that is lost, and this is also sometimes known as unaccounted water. That means there is no way to measure the amount of water that is being lost in this particular way. And this 15% is a very, very conservative estimate. So you can always go for a higher estimate based on that particular city. So then we come to the final demand, which is the fire demand. Now fire demand is important because suddenly if there is a fire, we put lot of fire engines to fight that particular fire, and suddenly there is a huge demand for water, right, extra demand, which is not the normal use, and because you cannot predict a fire, it can happen any point of time. So the quantity of water required for firefighting, this has to be kept stored in a storage reservoir. So we have to keep this water stored, and we have to also make sure that it is always available. So it's not like we will when the fire breaks out, we will take the water from domestic use and redirect for fighting the fire. It's not like that. We keep certain amount of water which would be stored for fire. And the water distribution system is affected by fire demand, since consumption of water during firefighting is high. Because why? Because firefighting is usually fire is fought with a higher pressure, and because you are putting in suddenly lot of new fire pumps into the system, and they draw water at a high rate, automatically there would be some changes in the water distribution system. So we have to design our distribution system which would be able to take care of that. Now how do we do that? So we usually put in this hydrants, and these fire hydrants are usually placed around 100 to 150 meters apart along the water mains. Water mains are the main water lines through which we supply water. So along that water mains, we usually put fire hydrants at 100 to 150 meters, and because this is the main water line, there is both adequate water available, and also even though we draw water from this particular line, there would not be too much fluctuation or too much reduction in pressure. And 3 jets. So what we do in each of this fire hydrant, you see that usually you see there is a post, and you see this this openings at the post from where we, this pipeline is being connected, and these are usually at the side of the roads. You will see this kind of particular fittings, usually marked red in color. And then what you do is, whenever a fire breaks out, this fire engines will come. They will feed those firefighting pumps into these fire hydrants. Usually in each fire hydrant, we connect around 3 pumps, and 3 jet streams are connected from each of this fire hydrant, and each of this stream discharge around 1100 liters of water per minute. And the pressure that has to be available in this kind of fire hydrant is around 100 to 150 kilonewtons per meter square. Why this kind of pressure has to be available? Because usually this 100 to 150 kilonewton is also known as 10 to 15 meter head of water. Now, what it means is, that means if you can direct the water upwards, it will go to a height of around 10 meters to 15 meters, right, depending on the pressure that is there. So, this kind of firefighting has to be maintained for around 4 to 5 hours, and so you can understand the amount of water that would be drawn, because 1100 liters per minute, you multiply it with 4 hours, and depending on how many number of hydrants that would be connected. So, you can understand the total amount of water that would be used for this particular fighting fire. So, either we can determine that total amount of water used is a function of the number of fire hydrants that would be engaged to fight fires, and usually because these are 100 to 150 meters apart, we utilize 1 fire hydrant to fight 1 fire, and that means we can take 3 connections from this and we can fight the fire. And so 3 multiplied by 1100 liters per minute into the time period for fire, that actually gives us for the amount of water required to fight 1 fire. But at a certain point of time in a city, there could be multiple fires as well. So, we will multiply that and we can determine the fire demand or the amount of water required to fight fire for a particular day, for a particular city. There is another way. So, this is one way. The other way is, this could be done for small cities and small, if the population is within 50,000. But if the population is more than 50,000, in that case we usually go for this particular formula, where fire demand in kiloliters can be also estimated as a function of population in thousands is equal to 100 into root p for cities with population greater than 50,000. So, root p is population in thousands, not the actual population, but actual population divided by 1000. And so, this can be also used to estimate the total fire demand for a particular urban area. And finally, there are several empirical formulas also being empirical formulas basically means wherever for a particular area, based on observed values and all, researchers have deduced certain equations to actually predict a certain kind of event or a certain kind of requirement, like in this particular case, the amount of water required to fight fire. So, Quichling's formula Q equal to 3182 root P gives the amount of water in liters per minute that is required to fight fire in an urban area with a population P. And P is of course population in thousands. So, this actually tells us that is the amount of water that is available in liters per minute, and then you can obviously multiply this value with the amount of time that the fire would be fought, and from there you can also determine the total amount of water that would be has to be stored. So, this is Quichling's formula, and using this we can actually determine what is the water requirement just for fighting fire. Now, let us see this particular problem. In a big city having a population of 10 lakhs, if 4 fires break out in a day and each fire stands for 4 hours, determine the total amount of water that would be required. Solve using different methods. So, even though the first method is not for large cities, but still we use that first method as well to see how much amount of water would be estimated using that particular method. So, here we see that amount of water required per person is equal to the number of fire into discharge in minutes into and the amount of time for that particular discharge, and then we divide by the total number of persons to determine amount of water required per capita. So, 4 fires 1100 liters per minute, and minute is now because it is in minutes. So, we are converting 4 into 60 because 4 hours 60 minutes, and then divided by 10 lakhs, and we get around 1.06 liter per person per day, or alternatively you can say 1056 kiloliters per day. So, this is the water requirement when we use this particular formula. But as we know that this is applicable for smaller cities with less than 50,000 population. So, we use the alternative formula where we determine the amount of water required in kiloliters per day, which is 100 into root P in thousands. So, 10 lakh divided by 1000, we get around 3162 kiloliters per day. So, here we were getting 1056 kiloliters per day. So, in a large city we can get around 3162 kiloliters per day. Why it is different? Because you can understand here we are estimating 4 fires are breaking out, and accordingly we are estimating. Over here we are not doing any kind of estimate of how many fires are being breaking out. We just straightforward say this is we assume probably there is more than 4 fires that are breaking out in a particular city. So, accordingly it is giving around 3162 kiloliters per day. And similarly, if I use Kuchting's formula and we put in the population figures over here, we find that the requirement is around so this is around 1 lakh, something around 1 lakh liters per minute is the requirement to fight fires in this particular city. So, this is how we can estimate the fire demand for a particular area. And you can see that we have to add another 1 liter per person per day, per capita per day, into the overall demand for fire. Something around 1 liter to, or if this is taken, then maybe around 3 liters in this particular case. So, what are the different factors affecting per capita demand? We already in the last lecture discussed different factors which affect the per capita demand in particular cities for particular urban areas, or for just predicting water demand in a particular area. But when we talk about this particular standards, we say that there are different cities are of different characteristics, and accordingly each of these cities require different kinds of water. Why? Because like for example, a small city will don't have usually it's a semi-rural city or a semi-urban character is there, or if it's a large city like 10 lakhs, then there could be lot of other kinds of uses that are there, like for example there is a lot of public use and so on. So, we usually see that like for small cities the demand per capita per day is around 110, whereas for large cities it may be around 335 to 360, right. So, these are the variation in demand among the different cities, and it varies as per like bigger cities have got more affluent population, more public places to maintain, sewer networks, and more commercial and industrial activities. So, that actually leads to higher demand. So, within our standard also we can see that there is variation in the amount of water that is required in different types of urban areas based on these kind of factors. So, it is very difficult to say that exactly what value would be required for a particular urban area, but this is where you have to make a call based on the characteristics of that city, based on these different factors, what amount of water has to be supplied. Now, just if you remember, last time we talked about, when we talked about domestic use, it was around 200 liters per capita, whereas now it is showing around 335 to 360 liters per capita. So, how does it happen? So, total is 335 LPCD. This is actually a combination of 200 liters coming from domestic use, 50 liters coming from industrial use, 20 liters per capita coming from commercial use, public use 10, and waste and losses around 55 liters per capita. So, again as I told you, if it is 15%, 55, but if it is 50%, you can understand it will be much more. So, based on population this varies in India, and so when you add all this up it becomes 335. And so, we usually see a range around 100 to or 110 to 360 in Indian cities, right. So, this is the water demand per capita. So, this is not the water supplied, this is water demand. So, we see that in Delhi this value comes to around 244. This is consumption based on water available and all, what amount of water is actually consumed. So, this is what is we found that Delhi around 244, Mumbai around 296, Kolkata around 226, Chennai very low 115, maybe water is not available there, New York 450, some places in New York is much higher, Singapore is 141. Maybe they are reusing lot of water. So, that is why this value is less. So, they are using lot of water, but they are actually reusing it again. So, that is why the fresh water demand is much lesser. So, this is the kind of demand that we can actually predict or actually assume when we adopt when we are doing a certain project or when we are trying to estimate certain demands for certain kind of water supply network or water demand for a particular urban area. So, the factors more or less remain same, the factors which affect per capita demand, climatic conditions, consumption more in hot and dry places and also more in cold places. Why more in cold places? Because in cold areas more leakage due to contraction of pipes and people keep tap open to avoid freezing of water. So, that actually leads to more wastages, right. So, climatic conditions do play a role, living standards of people, industry and commercial activities, quality of water supply, pressure in the distribution system. Now, if pressure is higher because the pipelines are not watertight, there are leakages, then there are joints through which water comes out. So, more is the pressure, you will see more leakage and so these are the problems when you have more pressure in the distribution system. Then system of sanitation, if there is a sewerage network, it requires more water. System of supply, if it is intermittent or continuous, that will also affect the amount of water that is required. And cost of water and metering, to some extent it also determines. Metering actually reduces the pressure and also there are losses over there because of leakages. So, that actually increases the water requirement, but cost of water may not be that much, but still it plays a role. So, these are the factors which is similar to the factors that we discussed earlier. So, these are the factors which you have to consider while we assume a particular standard of water requirement for a particular area, right. So, these are the different things that different factors which you need to consider. And to conclude, we can say that water demand in Indian urban areas are estimated using IS 1172/1993. So, these are the standards you need to adhere to. Per capita demand in Indian urban areas range for around 100 to 360 LPCD, and per capita demand in Indian urban areas varies based on different factors which needs to be considered while determining urban water demand. These are the references you can study. Thank you.